Good afternoon. This is CFRG IETF research group. I hope you're in the right place. So I hope you all see Note well more than once, hopefully 100 of times by now. IRTF is covered by similar Note well. So we have a Jabber note taker, we have a PO of thank you, we have a person who will who can relate comments to the mic. Let's get started. So this time I'm the only co-chair. Kenny couldn't come to Yokohama, so it might be a bit challenging for me, but I'll try. So quick agenda bashing. Any comments on this? So I'll talk about documents, then there would be slides from Simon about EDDSA. Then there would be one presentation, well, actually two presentations, and then we'll have an open discussion about what people think CFRG should be working on. I know it's a bit of a rat hole, but I think it's time to hear some opinions. Yep.
Yeah, so one thing that would be good to discuss is this topic of the lifespan of algorithms in terms of how many blocks you can cipher with them. So there's a discussion on the list under the under Jeffsov and Watson and a sort of other people about OpenPGP, but it's also an issue for TLS. So
right.
You know what I'm referring to?
I vaguely remember the thread.
Right. So the question is basically, what is a safe bet parameters for how many blocks or records, depending on the structure, you can encipher with, say, GCM? And so it'd be nice, from the perspective of TLS, it'd be very nice to have an answer to this question.
Right. So how much time do you think?
I don't know, DKG. How much do you think we need? So total 10 to 15.
Okay, so you will go after no MTI crypto without public review, okay?
I don't have any slides.
That's okay. No slides necessary. I am currently quite jet lagged, so if I happen to forget, please do remind me. So, quick update on document status. We haven't published any RFC since Prague, but we have a couple of documents in RFC editor's queue. Dragonfly is finally being in auth 48, and Kurt's document went through ISG review very quickly, and it's now happily sitting in RFC editor's queue, so it will be finished quite soon. Yay! We do have several other active documents in the research group. There is a new document on EDDSA signature algorithm. by Simon and Ilari. They are planning to do an update, and I'll talk quickly about list of issues. They cannot be in Yokohama, but they provided some slides for me to present. We have several PACI-related documents. We have requirements. We have 2 specific proposals. We have drafts on hash-based signatures. And David Magru also updated his own draft, which we tried to accept as a research group document a year ago, but nothing happened. It expired. So I haven't looked at all the changes. I think we'll need to figure out whether we want to have both documents in the research group, or what the status of this is going to be. There is also related work by Paul Hoffman about fundamental ECC. This was, he started this. This was sort of delayed because we were selecting new EC curves. And now that this is done, this is probably can be restarted. Any comments, questions on this list so far? So Simon and Ilari send chairs update and list of issues with the document on EDDSA. So I think it was a month or month and a half ago, 00 was submitted. It was pretty much a copy of Simon's original document on EDDSA curve 25519, but it also included ED448 section, which was pretty much cut and paste and amended as required. It's now refers to CFRG curves draft for curve details. So for ED at 25519 and prehashed variant, they're pretty much done. Some missing test vectors needed to be added, but for there was recently quite a big discussion on hash choices for ED448. And there is also some editorial work outstanding, like making sure that security considerations are up to date and that terminology is consistent with the curves document, which is in RFC editor's queue. The discussion on the hash options was quite active in the last couple of weeks, or maybe longer. There are 3 or 4 different proposals, both for key derivation function and for the prehashing function. It's not very clear which version has preferences, so unless somebody wants to make a very strong argument about particular choices here, I think chairs will probably do a poll on the mailing list and try to figure out specific choices. I think that's it. Do people want to discuss hashing functions here? Oh, it has to be Stephen.
Stephen Pratt. No, this is easy. I actually just wanted to say thanks for actually picking something. That's all.
Okay. I can tell you that chairs were very surprised when we had actually 5 proposals for signature schemes, you know, before Prague. We were very, very surprised, but we had to narrow down choices. So I think the process was fair. So we.
So Brian Ford, EPFL, I'll be the bad guy. But so, you know, I don't have any significant, this is fine. It just seems a little crazy and unnecessary to require 2 different, oh, sorry, I missed that. That's SHA 35512. So, right, I do remember my concern. SHA 3512 for the pre-hash is the thing that handles potentially large messages, right? So I only have a performance concern with that because SHA 3512 is operating the internal Ketchak cipher at a kind of intentionally downgraded performance level to achieve kind of worst of all, kind of absolutely worst case kind of security assumptions, and that it just seems unnecessary to downgrade the performance like this. Were there any serious objections to just using Shake 256 for both of these? That was also proposed, I think, right?
Yeah, I'm not sure whether there were very many. A lot of discussions were about performance characteristics, and different people claim different numbers for.
Yeah, does the choice of hash function even matter for performance? I mean, isn't it all in the margins compared to the actual ED448?
Depends on the size of the message. If you're signing a 1 gigabyte message, then I say it matters.
Right.
Yeah, and so I mean, there's nothing wrong with using SHA 3512. I'm just a little worried that, if we just do this, then, people will start complaining about the performance. Well, the performance sucks. Well, yeah, why does it suck? Partly because we're running the cipher half as efficiently as we could by all security arguments that I'm aware of.
Have you made your statement on the mailing list, or?
Sure, yeah.
All right.
Mm-hmm.
Okay, so yeah, I think next step is there would be a poll on the mailing list to narrow down specific choices, and hopefully we'll get this done before Christmas. Okay, actually, sorry, I will change the agenda order a little bit. Rich, can you go and talk about your topic quickly? Because the last one is more related to.
Hi. Okay. No slides because I don't have any document yet. I'm writing a draft on why it's a bad idea to have any mandatory to implement crypto without the crypto being any kind of public review. We've seen a bunch of areas, problem areas, where we've had a TLS extension for entropy, dual DRBG, right? There's calls to do, we should just adopt this really nice little short symmetric crypto called SPEC. I don't actually mean for there to be an underlying thread to all of these kinds of things, but it just turns out that those are the 3 examples that come to mind. So if anyone has other examples of places where we adopted proprietary crypto and it turned out to be really bad and broken, I'd like to know that. There's other impacts on things being patented where it's hard to get public review for patent things, so like examples of that. And also as an argument for having crypto agility when we need to swap something out, secondary issue. Anyhow, contact me, rsols at akamai.com, rich.sauls@gmail, wherever. I'm easily found on the mailing list. I just wondered if anyone else had any comments at this point. I know it's a complete new thing, but feel free to catch me, be here all week, all that kind of stuff. Okay.
Ecker, let's have your topic now.
I didn't realize that the binding of after.
Yeah.
So let's see. There's been some discussion on the mailing list of the sort of lifetime of various kinds of ciphers, and the relevant point here is, say you have a system like a TLS, connection that has very, very long-lived interaction, and this can apply in any situation where you have a lot of data being pumped through the system. How long should you be using the symmetric cipher before you decide to flip the keys? This typically isn't actually, with modern ciphers, isn't an issue with the underlying cipher construction. It's an issue of the fact that probably you're using counter mode, and counter mode has certain properties that distinguish it from being distinguished from a real random number generator over long periods of time. The absolute upper limit, at least in the absolute upper limit typically for GCM is depending on the structure, 264 blocks, I guess, is what people are sat at. So TLS is 264 because anytime you have like a record-based protocol like TLS or IPsec, typically what you do is you break things up so you have a per record nonce, and then you have a counter inside the records. And a classical breakup is 64 bits for the record sequence number and 32 bits for the interior counter. And so obviously that means you can't do more than 264 records because you start to cycle. That's very serious. But as I recall, even the block limits are much closer to 264 than 296. As I said, there was some discussion on the mailing list about this between Watson and Andrei Jivsov, and I don't think Dave McGrew's here either. But somehow we need to resolve this because we need to provide guidance to applications for what they ought to do. This is particularly relevant for TLS because we actually removed the functionality to let you change keys, and if we need to change keys, we want to be able to take care of that. It's not a big deal, but it'd be nice to know now rather than know later. But even for systems which already have key changing functionality, there basically is no good guidance what to do in counter mode. There used to be good guidance to do in CBC mode, but that is now gone, so it's unfortunate. I don't know if anybody here feels qualified to talk about this. I feel almost qualified to talk about it. So maybe we need time for this, maybe we don't. But if we aren't going to discuss it here, we need to figure out what to do about it. I know what else you have another use case for this as well, right? This OpenPGP stuff. You want to summarize the issue?
Well, I wanted to raise an additional concern that was brought up about. Sorry, this is DKG. There's an additional concern about this for TLS 1.3 as it's coming out, which is that there's a room for padding in TLS 1.3. And the padding blocks will be all 0 blocks. And so one of the concerns that was raised was about being able to detect, a potential attack is to detect whether blocks are padded blocks or not. And that the limit may be even, if we know then that the clear text is all zeros for padded blocks, can you detect whether something is an all 0 block or not on the basis of collecting the tail end of the TLS records that have the padding and looking for collisions after a certain space? Does that actually make the limit shorter of what can be used, right? Because yeah, I'm not sure I fully understand the argument, but
so I mean, I can explain what the argument is supposed to be, though I'm not sure I follow it. Is that because GCM is a counter, you never repeat the key stream within the limits of the counter. And so the consequence of that is that if you encrypt if you have a copy of the key stream, which you get when you encrypt a very long run of zeros, the consequence is that you never ever see a repeat within that series. And so if you see a repeat, that tells you something about the data, namely And if you have like a sequence of mixed data where you're enciphering some values that are non-zero and some values that are zero, in principle, you might be able to distinguish which ones are which based on whether you're seeing repeats or not. I'm not sure I'm convinced by Andre's particular attack, but that's the general concept. Is there anybody here who feels like they know anything about this, or shall I just sit down and we'll take it on the list? Okay, I'm going to ask the chairs though I don't know what you ordinarily do for this kind of query from other people. Is there some way to spin this up so that we actually drive it to a solution?
Okay. Can you send me email? And
Okay.
I'll talk
I mean,
to
basically, this is a request from like TLS to actually get an answer to this, but I think it's also from a BGP. So,
I just wanted to remind that the thread in the TLS list about this started by someone calculating how much data you could encrypt with a single key, and he kind of made the mistake of dividing by the record length rather than multiplying by the record length, and got to something that was a lot of gigabytes, but only a lot of gigabytes when it should have been several petabytes.
Right. So I had a private exchange with David McGrew and Andrei Jevsov where they were also talking at some very small numbers. So I'm concerned about this.
And when you did the calculations right, it turned out that you had enough to encrypt the entire storage of the NSA with a single key. So it's probably enough.
Right. Well, so as I say, that depended on thinking the limit, I think, was 2 to the 64. But there's some concern that the limit may be quite a bit lower.
So Alexei, this is Sean Turner. If you need something from the TLS working group, we can figure that out. But I'm hoping maybe you could just say, we know that this is going to go in the security considerations of TLS 1.3. Now's your time to get famous.
Yeah, I don't think we need anything official, but I'll probably talk to you anyway, unofficially. Okay, so action item for the chairs to do something about this. Right. I think we're going through the agenda much quicker than I anticipated, but that might not be a bad thing. So next topic is identity-based authentication key exchange.
I'm Akihiro Kato from NTT Software.
Yeah, can you speak into the mic?
I'm Akihiro Kato. Yeah, I'm going to present with a new identity-based authenticated key exchange named FSU. And this presentation is based on 3 drafts in our slide, X slide. In recent years, an argument of IoT is a hot topic in IETF. Yeah, it is expected that from 2 or 3 billion devices will be shipped in 2020. Yeah, client authentication is required for the purpose of transfer to information security from device to server. To achieve client authentication, there is a need to store the current credentials and device and server. Credential will have several types. This presentation will be considered for the management of credentials and when dealing with a large number of devices. Next slide. Considering the use cases of operator manager around large number of devices by PSK-based credential. PSK-based credential provides simple and lightweight protocols. It is expected to spread for IoT world. This slide shows some example of the use cases. For example 1 and example 3, operators should send changed ID or password to the authentication path server and links those informations. For example 2, this achieves simple management, but there is a possibility of the password cracking because of unchanging ID and password. To take care of a large number of credential users can use simple ID and password, and the security level those cases used by list-based password attack. Next slide. This slide shows a development model for a PKI-based credential. This model is based on that CA is trusted third party. PKI-based credential resolve almost management cost over server side. Authentication server manages server secret keys and public information for the devices, like certificate and public key. This model has advantage for the compared to PSK model, that is public key and secret key as automatically generated by random. Next slide. This slide shows a deployment model for ID-based credential. This model is based on KGC as trusted third party as well as PKI-based. Master secret key and public parameters are omitted from this image. In this slide, ID is unknown. ID dash is unknown information for the factory. Immediately, we just that devices need not generate secret key. Second, I say that server-side manage just ID. IDs, it might not be random. IDs may be determined freely. Next. This slide shows PKI-based credential almost resolve deployment problems. To treat a number of credential ID-based credentials have other merit, just low cost of generation of both SK and PK for device and factory, and centralization of the key generation. That is KGC only performs generation of secret key. ID can be ruled. KGC and server can generate public key previously. That is say KGC can generate static secret key previously. Next. This slide shows what security model. This slide shows the overview of FSU key exchange protocol. Master public key and public parameter are omitted from this image. Also, KGC generates static secret keys for initiator and responder. Initiator makes ephemeral public key and send responder to with initiator's ID and public key. Then responder make ephemeral public key and send initiator with responder's ID. Then both pair compute and share session keys. Next. This slide shows what security model FSU depends on. FSU is proven security to be secure ID-based extended connected cloud security model. This security model is one of the most strongest security model and against the secret key leakage. Total five secret keys exist FSU protocol. Session key will be safe even if attacker get any non-trivial combinations of secret keys. In this figure, combinations denoted by circle are secure combinations of secret key leakage. Next. IDECK security model implies resistance of following four security street. Not extended, normal connected classic security model mainly implies MITM. Other three might not be implied. Next slide. IETF and ISO already had an IDAKE that and RFC 65339 IBake and ISO IEC 170-3 Smart Chain. This table shows comparison with FSU and other IDAKE. Pairing time is total count of server and client. Key site and payload estimated are using SHA-256. First look, you might see that SCC is best. The significant point of FSU merit is security model. Next slide. IBake and SCC are based on IDCK, not ECK security model. Each adapted security model have a little difference. This slide shows security model adapted to scheme implied against secret key leakage. Combination denoted by security are secure combination of secret key leakage. These two schemes are covered less combinations than FSU scheme. This is our motivation of standardization of FSU. Next slide. Main theme of this presentation is FSU key exchange, but we wrote 3 IDs. This slide shows that's why we wrote 3 IDs. Elliptic curve script can be divided to 3 layers. Elliptic curve, how to calculate scalar multiply and signing method. Also, pairing-based script can be divided to 3 layers as well as ECC. Next slide. We chose pairing layer as the optimal 8 pairing, and that is fastest pairing algorithm now. Its computation time is about 10 times or more fast as a Tate pairing defined as a von Franklin. Elliptic curves, we choose BN curves that have 128-bit security. It is suitable for calculate for pairing. Next slide. This slide shows security of pairing over BN curves. Security of pairing depends on elliptic curve, like using elliptic curve security. And the orders of G1 and G2, the DT are 254 bits. Totally hardness of gap bilinear Diffie-Hellman problem of our selected pairing have 128-bit security. Next slide. Future work. We are going to standardize key generation data for ID-based script as future work. Next slide. Any comments? I'm very quite local, not only for my draft. Any ask me.
Hannes Czefinik. I work for ARM, and we often get these ideas proposed to have different ways to provision the chips with some keying material. And the concerns that we typically have are around IPRs. is it any better than existing schemes that, for example, with certificates that people provision to devices? Does it make a huge difference? Because often once you start provisioning one piece of information, it doesn't matter whether it's 1 bit or 5 bit or 10 bit, you already start the process anyway. You need to negotiate, you need to do all sorts of things. So it depends on like what you really see as the main benefits over an established schemes. And the third thing is there's obviously some uncertainty regarding the security of those provided schemes. So that's probably the reason why some of the identity-based mechanisms haven't found widespread use, and that's why we use the sort of classical public key-based approach, and we use that in millions of devices, and we plan to use those also for IoT.
Your main question is KDC or safe?
So tell me on why. So for what devices do you think that this is applicable? Where should we use these type of things? Is it like, are you suggesting like set-top boxes type of devices, or is it like IoT-based devices, or where should we use those? Because initially you had vendor something that gave me the impression that you're talking really about device side. Right?
Initially condition of devices, we have not considered yet. Sorry.
Okay. Yeah. So if you, I can drop a mail to the list with some of those questions. Yeah, and then performance is also another question that I have.
Yep.
Okay. That might be a bit early to ask, but what are your expectations? What would you like to happen with these drafts? Are you happy to work on them by yourself? Do you just would you like some reviews from CFRG? Do you want CFRG to try to adopt them, or do you have preferences? I'll talk to you. I'll talk to you after later. All right.
Thanks.
Okay. I'm scared to think how much time is left for the last topic. You know, I'm not. I think we have 50 minutes instead of 20. Considering that, well, fingers crossed, until RFCs are published, you can never be sure. But one elliptic curve document is nearly done, and EDDSA seems to be heading in the right direction. So there are several PAC-related documents in the research group, as well as hash-based signatures. Kenny and I would like to start a discussion about where CFRG should concentrate its efforts and which topic, you know, CFRG should try to prioritize and work on. On this note, it looks like Steven has an opinion, you know, he's looking at me like.
No one wants to talk. Brian Ford, EPFL. So I would, so I already basically made this point on the mailing list. I would definitely support the suggestion DKG, I believe, made of looking into standardizing the way Merkle trees work. It's, you know, kind of a very fundamental primitive used all over the place in inconsistent and sometimes slightly, not usually seriously, but slightly broken ways. You know, it would be a way to kind of improve things there. Another possibly more kind of far-reaching, maybe kind of a distant thing. I brought this up in the context of the Open PGP mailing list and also posted a quick note about it on the HRPC list. And again, I don't know where it belongs, maybe here, maybe not, but the question of in encrypted data formats, whether for data at rest or data in flight, in protocols, kind of a cross-cutting concern. Can we develop protocols to not leave so much metadata unencrypted, like magic numbers and protocol numbers and, you know, unencrypted negotiation things that basically tell attackers exactly what kind of file this is, or exactly what kind of packet this is, exactly how long these TLS segments are, exactly what version of which protocol this is, exactly which old broken cipher like RC4 this stream might be using, without even making the attacker do any bit of analysis to discover that it's a, you know, old broken cipher. You know, there's a kind of a constellation of issues here, and possible solutions, but, you know, again, this is kind of longer term potentially. Just wanted to throw that out.
So would this be sort of recommendation for protocol designers?
It could, yeah. So the reason I bring it up here is it could be a cross-cutting concern for how to use crypto in a variety of protocols. But, you know, that's the only reason I suggested. I'm not saying it does belong here, but I wanted to throw it out.
Stephen Farrell. So yeah, I think some of that might, but probably big chunks of it wouldn't. You know, how protocols use fields is not particularly cryptographically related, but I mean, maybe something like, you know, how to, you know, mechanisms that make sense for using padding might make some sense. You know, so if we're adding padding to a whole bunch of protocols, then maybe there's scope for people from the cryptographic community to help with figuring out how to do that well in various protocol cases. So it's not like standardizing stuff, but just having the analysis, but because I think that's something we don't have in a lot of IETF kind of working groups.
Indeed, padding was one of the topics that I was particularly interested in as part of that. Yeah.
So in addition to, so I think traffic analysis is a place where we don't have much research that's actively been done, and I don't know, it's not exactly crypto, so I don't know whether people are okay with that. But we have, I think, multiple times in the last 2 years had people come and say, here's a post-quantum mechanism, and we've basically said, please don't bother us with that right now. We know it's important coming up, but we're trying to get this elliptic curve, new curves out the door. With the new curves looking like they might actually come out the door, do we want as a group to consider post-quantum questions?
Ecker, I would agree with DKG that that post-quantum is something that would be useful to know about. I think what frankly would be useful would be not necessarily, perhaps it would be useful to have a CFRG recommendation for post-quantum. I strongly suspect we're not ready for that yet. What would be useful would be here is a survey of the state of the art, and here are the things that we have, if you look at Cochrane reports, right? Here are the 85 post-quantum things we supported. Here are the ones we think probably work with, here's our level of confidence in them, and here's how much they cost in terms of various things. Would be a very useful piece of paper to have in one's hand. Right now I'm at the point where, where I'm like, I got to go call somebody who's an expert and get their opinion about it. But a consensus document that sort of reflected what the feeling of the working group was of how well the various post-quantum things work would be very useful. The other thing that would be useful would be some work on the interaction of compression and encryption. Since we started pulling compression out of our protocols, which is encryption because it's so hard to use safely, having some kind of guidance on is there some way to use it safely would be extremely valuable. Maybe perhaps the answer is no, but we spent like an enormous amount of mental effort just getting HPAC to work, and it still has leakage. So it'd be really nice to have a better, perhaps Plus a better threat model for what you actually thought about for compression, some sort of better security models, that kind of thing.
If folks are looking for sort of problems to chew on without having to directly address the post-quantum questions, but that are related to post-quantum, we've had several suggestions within the TLS working group about combinations of post-quantum schemes and existing like asymmetric schemes, like different Diffie-Hellman schemes combined with a post-quantum approach. So if you have analysis on the safe way to combine these two of these schemes so that it's no worse than the weakest of the two, that would be useful, right? Because the post-quantum is still really untested and unproven. No worse than the strongest. Yes, thank you.
Yes.
Yeah, let's do it that way. So people have proposed multiple combination approaches. So that with the idea being that, well, maybe this post-quantum scheme doesn't work out, but at least you still have the elliptic curve to fall back on. That obviously doesn't protect you against a quantum computer, but it would be really bad if it turned out that these combination mechanisms actually made things weaker than the elliptic curve stuff that they're trying to mix in. So if there's some clear analysis that says, here's how you do this kind of combination, even if you don't know whether the post-quantum scheme is right or not, I would love to see that because it would help us to make decisions going forward in TLS.
Robin Wilton from the Internet Society. Again, this is not 100% crypto related, but something where I think CFRG might have the expertise to give an informed view. And it's about anonymization techniques for data. It seems to me that a number of those use crypto-like algorithms or techniques. And increasingly, we rely on third-party assertions that something has been anonymized. Some guidance as to whether we can trust those assertions, and if so, for how long? Along the lines of, how long should you use a key for? How long is this way of anonymizing data likely to protect it for? Would be, I think, very useful in practical terms. Again, as I say, not 100% encryption related, but I think this group may have the skills to offer a view.
Hi, Johannes, speaking as a developer and writer of RFCs in the IETF. Especially regarding post-quantum cryptography, there was this publication by, I think, the NSA a few months ago, said that we have to start using post-quantum cryptography, and therefore you should use SHA-384 and P384 for key generation and signatures. And we were all expecting to have to use totally new algorithms. So this document was kind of confusing, and we would like to get more guidance from CFRG on which algorithms we should use, because it seems a little strange that we just need to bump up the key size and everything will be okay. It's probably not.
Rich Sauls Akamai, I want to plus one what Brian said about Merkle trees. It's used in certificate transparency. There's other proposals to use it now. So it's like 1, 2, we've got a trend. So I think it'd be easy for us to write the right guidance, and it would be ahead of the game rather than after things were already deployed.
Who is willing to co-edit and help out with this draft? And 2 hands is nice, but probably not, not quite enough.
Martin Thompson, I encourage the people getting up to the mic who have obviously taken their time and effort to stand up to be the ones to drive that.
So Stephen Barrell again. So Alexei, I guess there's a kind of a meta point though as well, right? I mean, to some extent, what we want to have is the cryptographers saying what they think is ready, which is asking this question in a different place probably. So
it's also a question of resource, you know, they are not going to, there isn't enough of them to answer every question being asked sometimes.
Absolutely. So no, what I'm suggesting is that maybe asking or trying to have this discussion at crypto or real world crypto or one of those, I think would be interesting, because then, I don't think that there's not too many of that kind of group here today, as far as I know. Maybe I'm wrong, but so I think I wouldn't just go on what people are saying. I want. But maybe also in those kind of fora, try and get somebody to say, what do you want to give us?
Sure. Very preliminary idea with Kenny was that there is Eurocrypt in Europe next May, and there would be another meeting in US, crypto related. So we might try to collocate CFRG sessions.
So I think something like that would be really maybe a good idea.
Just to try to reach out more to relevant people.
Yeah. Good. And so I think chess and real world crypto, I guess, are ones, right?
Right.
So so I think I mean, not just having like a bunch of IETFers say I want, but having people say, here's what we actually would like to work on, and we're actually people who know about crypto would be good too.
Yeah, CFRG is very interesting group because people who meet in the room are pretty much never the same people who are on the mailing list. So it's need to try to find how to engage.
Yeah.
So this is even more hand-wavy than the last thing I said, but one thing that would actually be really useful would be some way to get the people doing formal protocol verification involved in working with us better. So we've been doing a lot of that in TLS, working with like the group at INRIA and the group at Oxford and Royal Holloway, because the state of the art has gotten much better in terms of being able to do formal verification of protocols with theorem provers like Tamarin and Proverif and stuff like that. And right now it's kind of a black art, but it's getting less black. So again, I don't really know. I don't know. It's less like a working group action item, because that doesn't make any sense. But and these people do sort of have places to publish, but if there was some way to use CFRG to get a better nexus between that community and the community that does the protocol design here, that'd be useful. I do not have a good idea for how to do that, but it'd be nice to have.
Almost like a question for Lars.
Like I say, I mean, this is an active and exciting research area that really is starting to be able to feed into, real world into doing protocol design now.
So I think that's a good. That's kind of a good idea. But I mean, one way. I mean, I remember many years ago there was some guys came along with a result about Kerberos, and people found it very interesting. So maybe in that kind of case, just getting people to come along to a meeting or something would be good. Nominate them for the ANRP. Lars can tell you how. Is it still open, Lars? So there's a process. There's a way to kind of nominate papers that if there's work that would be just interesting to present, as opposed to be an ongoing produce a document kind of thing. Or else try and get Lars to give you some of his massive budget to just pay for a few of them to come along.
Okay. Any other topics? Right. Hold on.
Question, Hannes, so there's some work on these strong password-based authenticated key exchange mechanisms in CFRG that sort of relates to work in the TLS working group, and I was wondering what the appetite is, or whether there's a possibility to do some different techniques, standardized different mechanisms, including TLS cipher suites, or is that out of question?
Sorry, your statement/question is a bit vague. Can you try to rephrase it?
Yeah, I don't have.
So there is a requirements document, which yes, we first had a couple of proposals, and then we put requirements document, try to sort of organize the space, and Are you suggesting that we should work on the requirements document potentially
no, I don't
and
want to.
come up with some specific mechanisms as a result of this, as a next step?
I will think about my question in more detail and post something to the list, I guess.
All right. Okay. Anything else on this topic? Okay. I forgot to mention earlier that there was a request from W3C to help with web crypto algorithm overview document, and Harry Halpin just posted a message yesterday or today about this. So, yeah, come on.
Yeah, Wendy Seltzer, I could say a bit
Sure.
more about that. So Web Crypto API has a set of algorithms that are being included, and one of the requests we got was to review the recommended uses for those algorithms, because some of them are being included only for backward compatibility and are really not recommended for use in modern protocol design. So CFRG review of that document and improvement of the review so that future implementers have a place to look for best practices in using crypto algorithms would be very helpful.
Yeah. I think Chair's default preference is to accept this document, and there are a couple of informal, well, there is at least one message of support. Well, it's message of support and also saying here's a lot of things you need to fix, which is exactly the feedback we need. So, so that's another work item for the research group to work on, hopefully in very near future. I think that's it for me. Any other business?
Congratulations on getting married.
On that cheerful note, you now have an extra half an hour. I donated half an hour to you all in celebration of my marriage. Thank you for coming.
What's that one about web crypto?
I can pre-filter it out. Yeah, I mean, don't we have data on clock skew? Hey, we could have data.
Also,